Well, a warm welcome to everyone joining. Thank you for being here. Go ahead and get yourself ready with a notebook, a pencil, or pen. Whatever you choose to write with is fine. This is math from the void. Math coming at you pretty much out of nowhere. And today we have a cutesy little SAT style problem that I thought about the other day, just because. Go ahead and give it a shot. It's sort of a free response question, but you can express your answer. I should have written this. You can express your answer as like a fraction. A little real time behind the scenes. There we go. So, without further ado, go ahead and read this problem over. Kind of related to probability here, so it's sort of a tricky probability question. And there are many ways to answer this question, so I am curious to see any different ways that were approached. Give yourself about, it only takes about a minute and a half, or really it takes less than that if you're good and know what you're doing here. You can pause the video to work that out for yourself first, and then you can unpause the video, come back, and see how we did it here. So, let's read the problem. I have to randomly pick two distinct integers. Distinct is important. That means they cannot repeat, first of all. They can't be the same. They like to throw in an occasional vocab word every once in a while just to see if you're on your toes and able to determine what that means. They can't be the same. And that little subtle detail completely changes the calculation. If you have 15 options each time you choose a number, that's different than having 15 options for the first and then 14 options for the second selection. Okay, so be careful with things like that. Find the probability that their product will be even. Yeah, so this is also going to test your understanding of what even is. You may think you know what even is, but do you know what even is? Do you really know what that is? Do you even, bro? I guess you could say. How do we know if a product will be even? Well, we're picking two numbers, and we're multiplying them. The only way that this is going to be even is if at least one of them is even. So we could have even times even is obviously going to be even. But we could also have, let's duplicate this a couple times. There we go. And there we go. So we can even have an odd times an even, or we can even have an even times an odd. Doesn't really matter there. But instead of adding all of these different scenarios, what would be more clever? Because we've already covered 3 of the 4 possible situations. This covers 3 of the 4 possible, how should we say, cases or scenarios. The only way that we can multiply two integers is if we have an even times an even, or an even times an odd, or an odd times an even, or an odd times an odd. So if we want the product to be even, another way of interpreting this is that we want the product to be not odd. And we don't have to worry about 0 because none of the numbers are 0. But technically 0, I don't know, 0 even or 0 neither even nor odd. It's definitely not odd, right? But is it even? That's up for debate. You can leave your comment. You can leave your opinion in the comment whether or not 0 should be considered even. I think it is, but you could probably make an argument that it's neither. Anyways, we want the product to be even, which means we want it to not be odd. So that means we can exclude, that's just a mathematical word for subtract. We can subtract the case where we have an odd times an odd. And we want to find the probability that this happens. So in order to calculate probability, let's remind ourselves that the probability of an event happening equals the number of ways for the event to happen divided by the total possible number of outcomes. Okay, so the total possible number of outcomes is like 15 times 14. That's not a 14. 15 times 14. 210 total products. Distinct products, that is. So that's treating 3 times 7, or 3 and then 7, as different than 7 and 3. So how many odd products do we have? We want the probability of a not odd. So let's see, the probability of an even is equals to, because there's no 0 involved, it's the probability of not odd product. So this is going to be the total possible number of not odd products over 210. And the way we can do this is we can find out how many of them are odd. So if I have only odd numbers to choose from, that's going to be 1, 3, 5, 7, 9, 11, 13, 15. Those are the 8 odd numbers that I get to choose from. And so the total possible number of odd times odd products is going to be 8 times 7, or 56. If we don't want them to be odd, that means we want the remaining from 210. That's going to be 154. So we're going to have 154 products which are even because they're not odd over 210. And this doesn't look like it simplifies, but it does. If you just cut it down piece by piece, you'll see it. I'll do it nice and slowly for you. We have 77 over 105. Well, I know 77 has some factors of 7 and 11. 105 is also divisible by 7. And that leaves us with a probability of 11 over 15. So in this case, we're using something called the complement. In statistics and probability, the complement, or I think it's mostly a probability term actually, the complement of something basically means not. Right, so if I'm rolling a 6-sided die, there are 6 options. The probability of getting a 5 is 1 over 6, but the complement is the probability of not getting a 5, which is basically all of the other possibilities. So if we want the probability of something that's even, that's the same thing as the probability of it not being odd. So we take all the possibilities, 210, and subtract the odd ones, and that leaves us with the number of not odd ones. Okay, so kind of tricky because there are many ways to do this. If I wanted to, I could add all of the even combinations and then add all of these combinations somehow, carefully. But I don't need to do that. I could just subtract the total number of possibilities. Or I could take all the odd products and subtract that from the total number of possible products. All right, I think that's enough blab out of me on this one. I'll see you guys next time.